Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm here. Let's learn of enzymes. We know that proteins are polymers of amino acid, and since there are 20 amino acids in the body, and each protein has hundreds of amino acids, there are a mind-blowing number of possibilities for primary protein structure. This is how protein can be so diverse and serve so many functions in the body. One type of protein is called an enzyme. An enzyme is a protein that serves some catalytic function in the body. Remember that a catalyst is something that lowers the reaction energy of a reaction. An enzyme catalyzes biochemical reaction. These are critical molecules for living organisms because nature can do chemistry like we do chemistry in the lab. In the lab, we can throw anything we want. In the lab, we throw anything we want into a flask and heat it up, cool it, don't use strong acid and base or any number of strange exotic compounds. But inside your body, nature has to do chemistry at body temperature and natural pH. Only with the material at hand and using only the reaction is stumbled often by blind change over the past few billion years. An enzyme takes a chemical reaction that will be nearly impossible inside the body and make it up to a trillion times more favorable, such that it's feasible to occur on a normal biological time scale. So, how do they work? Well, every enzyme has a specific substrate, and the enzyme recognizes its substrate with extremely high specificity. So, it's kind of like a lock and key, where a specific molecule is the key that activates the enzyme function. There is a specific area on the enzyme that the substrate will bind to, which is called the active site. The substrate will be bind to the active site because it has just the right shape and composition to do so, meaning it's in the right size, but it's also has function groups that make favorable electrostatic interaction with certain key residues in the activities of the enzymes, whether those are van der Waals interaction, hydrogen bonds, or any other interaction of this type. The substrate might fight into the active site as is, or it might cause an index spike. Will the enzyme change shape slightly once the substrate is inside? But either way, once the substrate is inside the active site and binding has occurred, a number of things may happen. One possibility is that the enzyme causes the substrate to bend in a particular way, which is the will done in order to make certain interaction with the enzyme. And when it is bent configuration, some of the bonds become weaker and easier to break. This is one way the enzyme qualifies as a catalyst. The molecule will have a hard time breaking apart on its own, but in the conformation induced by the enzyme, the activation barrier associated with the reaction is much smaller. So many enzymes help the task of breaking down large molecules like the ones we eat to form the tiny components that we can use to build our own biomaterial. Once the enzyme catalyzes the reaction process the altered substrate leaves, and the enzyme can then go and catalyze another reaction. Enzymatic activity is always heterospecific, meaning that if a substrate can access as to a mirror image, only one of those forms will fit into the active site of the enzyme. Most enzymes have names that end in S, so you'll know an enzymes when you hear one. The rest of the name usually has to do with what the enzyme operates on. For example, the enzyme lactase break down lactose, the sugar found in the milk, into two smaller sugar. We will learn about the types of molecule next. It is a deficiency in lactase that causes lactose intolerance in some people. Because without enough of this enzyme, it is very difficult to digest lactose, as nothing is present to break it down when ingested. But breaking down molecules into phases is the only thing that enzyme can do. Let's look at the categories. We already mentioned enzymes that break down molecules, and thus could be a hydrolase, which catalyzes the hydrolysis of a chemical bond, which effectively separates a molecule into two phases, or a lysis, which also cleaves covalent bond, but by means other than hydrolysis. An enzyme with the opposite function, a ligase, is an enzyme that joins two molecules together. A transferase is an enzyme that transfers a function group from one molecule to another. An isomerase catalyzes a spatial rearrangement of the substrate. And one oxidoreductase is an enzyme that transfers electrons from one molecule to another. Sometimes, when an enzyme operates on its substrates, they will temporarily become covalently linked. This can happen if a residue in the active site has a nucleophilic group like the hydroxyl group in serine, which can react with electron deficient atom, and the substrates can act like an SN2 reaction. Sometimes, an enzyme simply does acid-base catalysis, meaning it either donates a protein or accepts a protein from some functional group on the substrate to make it more reactive. An example of this is when a residue in the active site is acidic, like lysine, which if proteinases at the amino group, can donate this additional proton. Sometimes in order to function, an enzyme requires certain cofactor or coenzyme. This is some other thing that must also bind to the enzyme before it can operate the substrates. Cofactors are things like metal ions, whereas coenzymes are actual organic molecules like vitamins. That's why we need to get all our vitamins, so that our enzymes. So you can see that there is a great variety of enzymatic activity, and all of is biologically crucial. Certain enzymes break large molecules down into the small components we need for other enzymes to the breadth of all the biomolecular bodies, which is constantly happening in every cell in our bodies. We will come back to enzyme later, but for now let's move on to some other biomolecules. Thanks for watching. Wassalamualaikum warahmatullahi wabarakatuh.